Hey everybody, welcome back. So we're talking about stoichiometry. And again, with stoichiometry, what's going on here, we're using balanced equations to make predictions about what we can get from a reaction, what the outcome might be. Okay. Yesterday you did mole to mole conversions. Today we're going to look at gram to gram conversions. Okay. Because remember, in chemistry, the mole tells us how many atoms or particles we have, but in a lab, we're still going to measure we're still going to measure mass using a balance, which is going to measure in grams, okay? So we may want to be able to predict how many grams we'll get from a reaction, okay? And we can use balanced equations to do that. Keep in mind the coefficients when you balance an equation, that's a ratio in moles. And that will allow us to convert from one thing in the reaction to some other thing, one of the other reactants or products, okay? And keep in mind your method for doing stoichiometry, okay? How does it work? What's your method? You have to balance the equation and then be sure your starting units, whatever amount you're starting with, whatever amount you know, you want to make sure that you're in moles or grams or liters. And then you choose your pathway, and then you set up and complete the problem. Okay. Now again, today we're going to look at gram to gram problems. In doing this, oh, here it is. Sorry, give me 2 seconds, everybody. Okay, so you're looking at gram to gram problems, which is the second pathway. Okay, so when you convert from grams to grams, you assume that you know how many grams you have of a certain substance in the reaction. Okay, you then have to convert from grams to moles. So to do that, if you remember the mole roadmap from a few weeks ago, you have to divide by formula mass. Okay, so you add a second fraction, where the denominator is the formula mass of substance A, and the numerator is 1 mole of substance A, and that's literally 1 mole of whatever the compound is. In the denominator, you put the formula mass. And again, the formula mass, you add up the average atomic mass of all the atoms in the formula, okay? In this next step then, this is much like this fraction from yesterday in the mole-to-mole problems, okay? In the denominator, you put the coefficient for substance A from the balanced equation. And in the numerator, you put the coefficient for substance B from the balanced equation, okay? And then your final fraction, in the denominator, it's literally 1 mole of substance B. A lot of times students are like, what do I put here? I don't know what I put here. You put 1 here, and you put 1 here, okay? 1 mole of substance A, 1 mole of substance B. And then in this last fraction, the numerator is the formula mass of substance B, okay? So let's look at 2 examples, okay? We'll start with this. So the first example, we have one of our equations from yesterday. Hydrogen and oxygen react to make water, okay? So step 1, balance the equation. 2 oxygens here, only 1 here. So we can put a 2 there. So 2 and 2 oxygens. 2 times 2, 4 hydrogens. So to balance that out, we put a 2 over here. So the coefficients 2, 1, 2 balance the equation. And again, think of that as being like your recipe. 2 parts hydrogen to 1 part oxygen give you 2 parts water, okay? Or 2 moles of hydrogen and 1 mole of oxygen give you 2 moles of water. Now the example, the scenario, 40 grams of oxygen, how many grams of water are produced, okay? So your pathway here, again, is grams to grams, okay? So we're going to start by putting the known amount over 1. We know that we have 40 grams of oxygen, okay? So I'm going to put that over 1. Now, the next fraction, basically here, I want to cancel out grams of oxygen and go to moles. Okay? So you can see here in the next fraction, 1 mole in the numerator, formula mass in the denominator. Okay? So I'm going to put 1 mole of O2 in the numerator. That is an O. Sorry, it's kind of narrow, but it is. In the denominator, I want to put the formula mass for oxygen. So here you need to use your periodic table. And again, if you look at oxygen, okay, that's not a very good zoom, but oxygen, average atomic mass is 16, and we have 2 oxygens. So 16 plus 16, 32 grams of O2. Okay? So grams cancel out, and we now have moles of oxygen. The next fraction, we're going to use our coefficients from the balanced equation. Okay? Moles of substance A on the bottom, and this substance A here is the oxygen, what we know, what we're starting with. And substance B is the water, and its coefficient from the balanced equation. Okay? So coefficient for water is 2. So we'll put 2 moles of H2O. And again, remember, these coefficients are a ratio in moles. On the bottom, coefficient for the oxygen is 1. 1 mole of O2. Okay? So this fraction allows us to convert from oxygen to water based on this recipe, so to speak, this balanced chemical equation. So moles of oxygen cancel out. Final step, we want to know grams of water, okay? Not moles. So again, looking at our pathway, last fraction, 1 mole on the bottom, formula mass on the top, okay? So in the denominator, 1 mole H2O, and on the top, formula mass. So H2O, I'm going to add 2 hydrogens to 1 oxygen. Okay? 16 plus 1.01 plus 1.01 is 18.02, and that's grams of water. Okay? So moles of water cancel, and I'm left with grams. Okay? So at this point, the desired units are in the numerator by themselves. Okay? All you have to do is the math. Multiply across the top, multiply across the bottom, divide top by bottom. So basically it's going to be 40 times 2 times 18.02, that product divided by 32. Take a moment, pause the video, and see if you can calculate that. Okay, your answer, and I'm going to round to 3 sig figs. Why? The original measurement has 3 sig figs. Okay? 45.1 grams of H2O. Okay? So if you do this reaction and you have 40 grams of oxygen and enough hydrogen to react with it, you will get 45.1 grams of water, which is about 45 milliliters, or about 1.5 ounces of water. Okay. All right. Let's look at one more example. Again, another one of our reactions from yesterday. The other one we looked at, aluminum plus fluorine gives you aluminum fluoride. Okay. So step 1, we have to balance the equation. Take a second and try to do that. Okay, so again, we put a 3 here, and a 2 here, and a 2 here. And that balances the equation. 2, 3, 2. Okay? Now, the problem then, 23.3 grams of aluminum. How many grams of aluminum fluoride? Okay? If you'd like, take a moment now to pause the video and see if you can solve this one like I did the previous one. Okay, let's walk through it. So, what was that? 23.8 grams of aluminum, and we put that over 1. Okay? Next step, on the top, 1 mole of aluminum. On the bottom, formula mass for aluminum. Now for a single element, like aluminum, its formula mass is simply its average atomic mass on the periodic table. Okay? So for aluminum, 26.98. 1 mole of aluminum is that many grams. So grams cancel out, and we're in moles of aluminum. The next fraction, we're going to use these numbers from our balanced equation, our mole ratio. So on the bottom, in the denominator, 2 moles of aluminum. And again, if you're like, where does the 2 come from? It comes from right there. Okay? 2 moles of aluminum. Aluminum fluoride, 2 moles of aluminum fluoride. Okay, so moles of aluminum cancel out, and I'm now in moles of aluminum fluoride. Final step, I need to convert to grams of aluminum fluoride. Okay, so on the bottom, 1 mole of aluminum fluoride, like so, and that cancels out. On the top, guess what? The formula mass of aluminum fluoride. So you're going to add up, the formula. And again, these coefficients, let me say, are never part of the formula. The formula of aluminum fluoride is AlF3. The 2 isn't part of the formula. It's just the coefficient for the specific chemical reaction. Okay? So the formula mass, 1 aluminum plus 3 fluorines. Okay? When you do that, you get 83.98 grams of aluminum fluoride. Okay? Squeezing the G there. 83.98. Okay? So here then, you do the math. Okay? These 2's cancel out. Makes it a little easier. 23.8 times 83.98. That product divided by 26.98. Okay? So feel free to pause here if you want to calculate. Okay, so whether you calculated just now or a moment ago, your answer, 74.1 grams of aluminum fluoride. Okay? So again, if you're in a lab and you have this much aluminum and you do this reaction, you can predict that you should get that much aluminum fluoride. And that's stoichiometry. We're using these balanced equations to make predictions. Okay? There it is. All right, everybody. So, like the previous lesson, you'll have a few practice problems to try. In the next lesson, we'll look at some of the other pathways. All right. Thanks, everybody.